Any more
Yes,
questions
that
from
one.
yesterday? Oh yeah, look, I think Ariana and Zelda have found the page.
Yeah, that one. That's me.
All
Okay,
right, we
do you
might
have
have
any
time
more
for one
questions?
more.
One more.
Yeah.
Giovanna asked, how do you study things that are really hard to see?
Well, that's why we need dedicated instruments. We need, actually, it's kind of very interesting because we need technology to study nanotechnology. We need to make devices that are able to allow us and see, not with our eyes, but with other methods, right? Because we can also see with our fingers. We can touch materials like with needles, and we can sense how the surface is, right? So that's one technique. We can also use electrons. Electrons can interact and touch the skin of the atoms, and that's another way of seeing. So there are many ways, and in general, the tools are expensive, but because they are very complex and they require a lot of cables and wires and programming for running. But there are other instruments, like even a needle can just run through the surface, and the chemical interactions between the needle and the chemical the chemistry of the surface can make us also see what we have in there. Okay, so we again, there are many things that are hard to explain. I really need you to dedicate some more time and effort so you can understand, but it can be very simple or it can be very complicated depending on what you want to see.
Wow, that's awesome. I've learned so much about nanotechnology today. I hope you all have too. Can we get another round of applause for Dr. Angelica? Wow, that was great. All right. Unfortunately, though, today is over and it's time for you all to log off, but we'll see you next week. And next week, we'll talk about astrobiology, which will be really exciting. And perhaps there's more science that we get to eat next week. All right. But for now, it's time to go. So thank you all so much for coming.
Bye.
Bye.
Bye, everyone.
Thank you.
Bye.
Bye. Bye, Aleutian. Bye, Zora.
Bye.
Aleutian, okay. Zora also often needs help leaving, so we just have to put her in the waiting room. Dr. Angelica, that was great. That was awesome. I think it'll be a little easier with our older group. The younger group gets distracted really easily, as you see. So, yeah.
But it's good because it gives me patience and practice. Yeah.
Absolutely. We also have at least one student in the older group that you'll meet, William, who is very smart, loves talking about things, and I think he'll be the most probably engaged. He was quick yesterday when we were talking about the nanoscale to be like, did you know humans can sense things at 13 nanometers? Like, he gets very excited. So hopefully.
I have one question, because that's why I didn't say something, because when you said I know the billion for you is different for me, so that's why I got confused. So it got me thinking when you said that.
That was the example I gave them yesterday, because one of the nanoscale images was like 1 meter was a adult woman, right? Which is obviously they're a little larger than that. But then it was comparing it to 1 nanometer. So that was the example I gave them, was 1 billion times smaller, or a million times smaller than their hair. So I don't know for sure if they'll remember it, but that's where that came from. I'm going to go ahead and start admitting the 3rd through 5th grade.
Okay.
Hi, everyone. Oh, I see Neela. Hi, Neela. Hi, Chloe. Hi, Adifa.
I have something to say, though.
Hi, Alejandro. Chloe, did you have something to share, you said?
I'll send it to you.
Oh, wait. For a split second, I thought this was the other room, so you guys already know that I'm on my other computer.
All right. We'll wait just a second because I see someone that's trying to join from the waiting room, and we'll wait for them to actually get in the room. But who remembers what we're doing this week? What are we learning about? Oh, Neela, what are we learning about? You raised your hand.
I forgot the name, but we're learning about like little.
Keep going.
No.
Little what?
I
Do you need a tag and a friend for help? All right, Adifa, what are we learning about this week?
Is it nanotechnology?
It is nanotechnology. Great job, Adifa. All right. Well, 1 second. All right, I think we're ready to get going. And to begin, we have a guest speaker. Our guest speaker is Dr. Angelica Saenz, and so she works at UCLA in the Nano Lab. So she works in nanotechnology. She works in a special type of lab called a clean room that is extremely, extremely clean. In fact, even a single eyelash can mess up their experiments, okay? So it's a super clean room. And she does a lot about nanotechnology, making nano composites, one of the words we learned yesterday. And she also works on troubleshooting some of the instruments that we use to study nanotechnology. But I'll let her take over and finish talking about what we're going to do today. In the meanwhile, make sure you have a piece of paper and a writing utensil nearby, or a couple pieces of paper, and make sure you have your purple envelope nearby. We'll need some materials for later today, all right? All right, Dr. Angelica, take it over. Oh, Dr. Angelica, you are muted.
I'm so sorry. Okay, I'm sorry. Okay. Hello, everyone. I'm very, very happy of having you here today. My name is Angelica Saenz, and today, as you said, we are going to learn about nanotechnology. I hope that because you are a little bit older, you can understand what I am talking about and that you get excited about this field, okay? So I will start sharing my screen. Give me just 1 second. Okay. Okay, so what is nanotechnology? I think it's better if we step back and we remember some of the things that you learned yesterday. In particular, I am interested in you learning very, very well what the concept of nanomaterial is and what are nanomaterials, okay? Well, nanomaterials are unique tiny structures that measure between 1 to 100 nanometers in size. These materials are unique because their properties, meaning the characteristics of these materials, are so different from any other object or material or component that we experience in our daily lives, okay? And what is a nanometer? Well, a nanometer is a measuring unit that allows us to define the size of these objects. And they are 1 nanometer is equal to 1,000 million times smaller than 1 meter. What this means, this is so tiny that we will not be able to see it with our eyes. But how tiny? Okay, imagine you go to a party and you have a birthday cake that you have to split in 1,000 million pieces. How much cake will you eat? Almost nothing, right? So you will still hungry at the end of the party because that piece of cake will be very, very small. So I have another example of how nanomaterials look like and how small they are. Well, this is a carbon nanotube, which is a very unique type of carbon material, which is very similar to a piece of hair, like a strand of hair, right? But the diameter of this nanotube is 1 nanometer. So it is so small that the diameter is about 100,000 times smaller than a strand of hair. So of course, if we want to see it, we will not be able to see it. But if we are not able to see it, so why do we care? Why do we keep using it? Well, that's why we have nanotechnology. Nanotechnology is a field that allows us to study and manipulate nanomaterials to produce new or improved structures, materials, and devices. Here I have another example. So this is a scale, right? We have meters, and at the micro scale, which is something, well, let me go one step back. When we work with nanomaterials, we need to change from regular instruments to more sophisticated instruments. Why? Because at the micro scale, which is the scale that we can experience in our daily life, we can simply use our eyes, which are our most used instrument, right? It's very simple. We all have them. Hopefully it's working for everyone, but that's how we experience and we see things and how things are different, right? But if we want to study a cell in our body, or a blood of cell, or a skin cell, we need a much more sophisticated instrument. And that's why we use optical or light microscopes, okay? And as we reduce the size and we go even lower, like to study viruses or a piece of DNA or carbon nanotubes, we will not be able to observe them with a simple light microscope. So we will need other instruments, right, that will help us to understand what is there, and also to help us use them for creating new materials and devices. So how do we make new structures and devices? Well, in the general sense, we follow 2 steps. One is we select the material that we want. Let's say we want a flavor, a color, or a composition. We just need to pick what type of material we want to create. And then we actually go and create it. So we fabricate these materials. In general, there are 2 techniques that we use for creating nanomaterials. One is called the bottom-up method. Because why is called like that? Because it's basically like using building blocks, right? Like playing with the Legos to assemble atom by atom or molecule by molecule until we get a structure in the nanometer size, which is from 1 to 100 nanometers. Okay, it can be 1, 2, 10, 20, or 100. So we assemble all these molecules or atoms one by one, and then we have our material. On the other hand, we have other type of methods that we can use, and they are called the top-down methods. Here, instead of having to make pieces one by one and connect them all together, we have a chunk of material. And then we apply something. We apply force, we apply atoms, molecules to start digging and removing pieces until we have something very thin or something very small that we can call nanomaterial. Once we selected our material, our composition, we made it possible, we fabricate it, then we can proceed to integrate. Actually, this is the important part, because this is where we take advantage of the properties of nanomaterials and we create something that people can use. But what type of devices can we make? We can make simple things, and I think almost everybody has seen something like this. Glasses, prescription glasses. They have a collection of thin layers of materials, which are called thin films, that allow us to either protect our eyes from the sun, from the light from the computer, or can make the surface anti-fogging. If we have a face mask and we breathe, our lenses will not fog because we have an anti-fogging layer. In other cases, we can also have filters, or we can have like anti-scratching layers, which means that even if we scratch with like a key, or if we put our glasses in our pocket, they will be hard to scratch. So we see this type of nanomaterials in our daily lives. Some other applications are like smart paints. People use nanoparticles and they mix them with regular paint so you can cover your house, and these particles will interact with the light, so the bacteria or the mold will not grow on the surface. This way you will have a shiny and healthy room. Okay, so this is also very common, especially in hospitals or in places that have a lot of light. You can use this and take advantage of these materials. In other cases, this is a very similar applications. We all know that door handles are everywhere, right? And a lot of people are touching them and they can spread all the germs in the world in the handles. Well, they can be coated with a special type of material that can release ions or molecules that can attack bacteria at the surface. But also at the same time, it allows to protect the door handle so people will not scratch it very easily. In other cases, there are much more cooler devices, like flexible and wearable sensors. These type of sensors can be attached to our skin, and we can bend them, we can fold them, we can twist them, and they will not break. They are very useful because they are very light. So there is not something heavy that we will carry. It's something very simple, and they can help us monitor our health or diagnose a specific disease. But what else can we do? Well, we can basically use our imagination to create almost anything, especially things that can help us as humans to solve problems in our lives, right? Especially medicine. We can help make better medicines or diagnose a disease earlier so we can cure that person. We can also make batteries, right, which is in the energy field. We can make batteries that last longer and that when we dispose of them, they don't contaminate. We can also improve the communication systems by creating antennas, but also by making our devices to go smaller and to have a lot of storage capacity, especially for kids. Like right now, they take a picture every second. So imagine to have a lot of memory in a very tiny device. It is also possible to use nanotechnology for space exploration, like the Hubble telescope outside or the WebEx, right? Because they are out there sensing information from very, very far. And something very important that, and I like to talk about this, is for environmental remediation. We can use nanotechnology to clean water. We can remove heavy metals, bacteria, viruses, many type of components that can damage our health or that can be dangerous for us or for other animals. So that is also very important. And in addition, we can also create materials that are helpful in construction. We can use them to create a structure that can sustain a lot of pressure, a lot of heat, and we can have a very strong house or a very durable automobile, right? So, but there are many things that we can create using nanomaterials and nanotechnology. And talking about imagination, right? Today, I want to do an experiment with you so we together will learn about the advantages of using nanotechnology and nanomaterials. And today we are going to make something that is called a nanocomposite. But before we jump to the experiment, I want you to learn what nanocomposites are. Well, a nanocomposite is a mixture of material where at least one of the ingredients is a nanomaterial. And why do we care about mixing nanomaterials with regular size structures? Well, because by doing that, we can improve the properties or we can modify the response. For instance, we can create a fabric that we mix with some nanoparticles, and we can create fire-resistant gowns, right? So it will protect us in case of a fire. So there are many applications out there, from simple things like creating a flammable resistant material, but also we can create plastics that can that can help us preserve food for longer periods of time, right? Because if we mix particles with a polymer, then we can enclose the food and then they will not allow bacteria to grow or to the air to enter, etc. We can also make materials that are helpful for cars, right? We can mix with the rubber for the tires, and then the tires will not heat if you have to travel longer, or it will resist longer distances. But from all the cool things in the world, what I like the most is what we do with nanomaterials and nanotechnologies in the field of medicine. Why? Because we are able to help other people. Recently, it was developed this type of material, which is a nanocomposite mixing a polymer that has a lot of, that is a polymer, but it also absorbs a lot of water, and they mix some of nanoparticles. They call this hydrogel, and they use this for helping people cure faster. Let's say you have a wound in your hand, right? So if you put a little bit of this material, you will accelerate the healing process, and then your hand will be very good in very short time. And this might not be important for you, but it is important for people that have diabetes, and for them the healing process takes long time. In the same scheme, we have some nanomaterials, hydrogels, that are mixed with nanoparticles, and then they can help in the bone regeneration. Let's say you have a fracture, and if you put a little bit of these materials, the process of healing will accelerate. This is also helpful for, especially for elder people whose calcium is not as it used to be when they were younger, but also with people that have a lack of calcium because of any disease. So by developing this type of materials, we are helping others. But there is also something very cool. So there are some materials that are called self-healing materials. Why? Because let's say you have a wire, and that you are using this wire to light up a lamp. Well, if you bend this wire, it is possible that it will break, so the current will not be able to pass, and you will not be able to light up the lamp. However, there are some nanocomposites that have very tiny particles that melt with very low temperature. So when you break them, the energy that is released during the break, it will be enough as to melt this material, and then it will reunite the wire, and then you will be able to light up the light. So that's why it is so cool to use nanocomposites. And before we jump to the real experiment, I need to introduce some more concepts. Why? Because we as scientists and engineers, we are always in search for stronger, safer, lighter, and more durable materials, like this polymer, right? Let's say we like to play with a toy a lot, and we are always pulling and stretching. There will be a point with the poor polymer will break, right, and collapse, and if it releases a lot of energy, it can be dangerous. But if we add some nanoparticles, it is very likely that we will be able to make this material stronger, so it can resist a lot of load and pressure. And also it can sustain a large change in size and shape. Like you can see in this image here, right? The shape of this polymer has changed without breaking. So it is possible to do that. And how do we as scientists study this? Well, there is a very particular type of experiment that we use to measure the strength and to observe the deformation, right? And this is called the tensile test. Basically, we pull the material and we observe how it is deforming as we are pulling and pulling and pulling apart, okay? So those are the concepts that I wanted to learn. I wanted you to learn before we do the experiment. Are you all ready with all of your accessories? Yeah.
All right. Do you remember what you need, everyone? You should have your Mamba.
Yeah. While I make my table, you can gather all of your instruments, right?
So Neela, thank you. You had the fruit chews and the chili powder. We also need our template. So everyone make sure you get your template. I like that Juan put on his gloves. If you all want to be able to maybe eat your science after we do observations, you can put on your gloves for the experiment. In addition to the template, you need to get your pipette that looks broken. It's going to be our spoon for today. So it's going to have a hole at the top. This should be in the same bag as your pipette from yesterday. Sorry, Dr. Angelica, I didn't mean to cut you off.
No, it's totally fine. So I will be standing. You will be probably not be seeing my face, but you will see my hands. I want you to be able to see my hands because we need to do this experiment together, okay? So in addition, You need your Mamba shoes, right? You need a ruler or something to measure.
Chloe, do you have a question? Sorry, Dr. Angelica.
Fine.
You also need your measuring tape or ruler. Yeah, Chloe.
Did the ruler come? Because I don't really see the materials that we need in here. I only see like a lot of food in this picture thingy.
So you should have a bag with gloves and a pipette from like the pipette from yesterday. So in that bag, you should have the pipette that we're calling a spoon.
Yeah.
And then you should have your template.
Invented spoon.
Yeah.
Yeah.
So you should have this, you should have the template, and then you should have your measuring tape from Vet Science if you don't have a ruler in your bag. And Noah, did you also have a question? Or are you struggling to find your supplies?
Wait, is this one of the bags?
Yes, check inside there. The chili powder should be in there.
Is it white?
It's not white.
Oh, wait,
it's going to look, yep, but not the sprinkles. It's kind of like a red-brown color.
Okay.
My suggestion is do not wear gloves because we need a little bit of, we need to make them sticky. So I gave you the gloves for you to feel like a scientist when you do other experiments. But for this particular experiment, we can do with our bare hands. My suggestion, if you want to eat the candy after the experiment, wash your hands, okay? We also need a piece of paper and a pen or a pencil. Please, a pen and a pencil. And I'm going to make a drawing and I want you to follow me. So it's basically a table with 12 squares. We are going to do a table like this, 12 squares. And then we are going to put number 1 because we are going to make 2 samples, and then number 2. And then on top, we are going to have some letters.
Real quick, while Dr. Angelica does that, Noah, do you have a question?
I just came in because I came from school. I just don't know what we're doing right now.
Yeah, so we're going to be doing an activity with Dr. Angelica. You need to get your fruit chews from your purple supply, your Mamba, your purple envelope. Sorry, that's what I mean. You'll need your template. You need your chili powder. And you need this pipette spoon from Dr. Angelica. So the 2 bags that you need inside your purple envelope, one will have gloves in it. You don't need the gloves, but you need other materials from that bag. And then there's a bag with marshmallows in it. Inside that bag should be your chili powder. Juan, do you have a question?
I was just having trouble finding it.
Okay.
Is this where the
Nope, not that. That's our sunscreen. You should check for another bag that has other food items in it. I think Noah had found the bag. Do you see what Adifa is holding up? That's what your chili powder should look like.
These are the shoes. This one.
Yeah, you should have Mamba. Yes, like Adifa's holding up. Oh,
chili
or like
powder.
Sophia's holding up. Awesome. Yes, Noah, those are your fruit chews. Now you just have to find the chili powder.
Take 2.
Yes, William, you've got it. Yes, Juan.
Yes, take 2 of the Mambas. 2 Mambas. Take 2. Only 2. We need 2. Okay.
And then Noah, yes, that's your chili powder. Great job. And now you just find the bag with the gloves in it, and there will be a template like this. And you'll have a pipette with a hole in it for your spoon. Yes, like Adifa's holding up. All right. Yes, perfect, Noah. Now you just need to find your template, okay? And in the meanwhile, has everyone made the table that Dr. Angelica is showing us? Everyone quickly make your tables. We have to get started with the experiment. How else are we going to gather data?
Yes. So basically, we are going to be scientists for a day, and we need a table to record our data, okay? The importance of this experiment is that I want you to experience with your own hands how making nanocomposites is important for us. There's one person. There is one person that just joined.
There's someone in the waiting room. Don't worry about that. It's one of our K through 12 kids who struggle, or K through 2nd kids who struggles to exit.
Okay. And then this is the table, okay? The letter I here means initial. The letter F means final, and the letter T means time. Okay, and then we have two samples, 1 and 2.
Give us a thumbs up when you're done making your table and you have all your supplies. Awesome.
Excellent. Chloe.
Chloe, do you have a
Okay.
question or do you have all your materials?
I don't have a question, but like I have all my materials except that paper thingy you were showing up.
Okay. The template?
Except this one, this
Yeah,
template.
It's not in my bag.
Okay.
It's very tiny. Please take out your gloves. It might be in between your gloves.
Oh,
But
okay.
it should be in the same bag as your gloves.
Okay, when I will keep showing my table because I need everybody with a table. Don't wear the gloves.
Yeah,
Don't
Juan,
wear.
we're not going to wear the gloves. It'll affect our experiment, and so we're not going to wear the gloves today. But maybe next week you can wear the gloves.
Yes, the gloves are for you to feel like a scientist later today.
See, like
Excellent.
Sophia's wearing her goggles to feel like a scientist. Awesome. All right, are we all ready for the experiment? Can you give me a thumbs up if you're ready?
Did you find it, Chloe?
Yeah.
Yeah.
Okay. Okay, everybody has a table?
I don't have my chili pepper, so I'm just gonna use this.
You can try it.
I'm not sure if it's going to work, but we will try it. And actually, that is a very good experiment because we will see if it works.
Alejandra, do you have a question?
I can't find the broken toothpick.
That's okay. You're just gonna have to use your hands to sprinkle some chili powder, okay? So you'll have to use your hands to pick it up instead of a spoon, but that's okay. All right.
Okay,
Are you all
everybody's
ready to get started? Awesome. Okay. I think we're ready to go, Dr. Angelica.
Okay, excellent. So now I have my table here and I want you to pay attention to what I will be doing, okay? First, grab one of the mambas, open. Everybody has the mamba open, okay? Now, please fold with your fingers like this and start mixing like this. Pressing, okay? Now that you have kind of like a mixture, use your table and then put your fingers like this, okay? And then I want you to start rolling, 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 rolling. You need to make like a cylinder shape, okay? How big? That's why we have our template. I want you to make a cylinder that is almost about the size of our template. Can you see? If you think it's not enough, you can start over. You can mix it again. Fold and fold and fold. And then your 4 fingers. And then start kneading. Rolling like this. And then I have my cylinder. Everybody has a cylinder? No?
Not yet? Okay.
It doesn't have to be too long. Remember, that's why you have a template.
And it doesn't have to be perfect, just approximate. We'll measure it. Don't worry.
Yes. It's not working?
Oh,
Juan.
Neela's looks great. Williams looks great.
Can you
Oh,
show me
Noah's
yours,
nice.
Juan?
Awesome. Can you hold it up with your
No.
template?
Like this. And where is your template? Like this. Oh, we cannot see.
There you go.
Okay. So now you have your cylinder like this and take one finger. I want you to take one finger and step in the middle of the cylinder and then start rolling. Rolling, rolling, rolling until you form like an hourglass shape, like the template, right? So you have to see something like this. Do you see something like this? Yes. Everybody has something like this? Yes, excellent. Okay, and then we leave on the side. We need to let our mamba rest because if we keep touching it and after we form this shape, then we will warm it up and it will recover, okay? So let it rest on the side. Now, for those who are ready, please open the second mamba. Get your chili powder. Place your mamba on the center of your hand and then get some chili powder, half the spoon, okay? Half of your spoon. If you add too much, it will be kind of complicated. So we need half the spoon. And then we sprinkle the chili powder on top. Okay? Everybody is here? Everybody is following me this step? Okay? So then we start mixing, folding until we mix the chili powder with the candy. We fold in our hand like this. And then when we see it's kind of mixing, we put our two hands together and then we start rolling. We need to make a ball. If you still feel like the powder is not really mixing, push. Push your candy again and it will become more integrated into the candy. And then roll again between your hands. Yes. Roll again so we can improve the mixture. Excellent. Okay, now we put our candy on the table. We clean a little bit of our hands. We put our 4 fingers together again. 4 fingers together. And then we start rolling again, okay? We need to start rolling. Like when we did the first candy. We need another cylinder. And we can compare with our template, right? We have our cylinder with chili powder. It looks about the same size. Yep. Okay. If you feel that is not very well, can I see it again? Chloe, can I see your candy? If we feel our shape is not very regular, we can roll again in between our hands. Okay, roll again. Then we put our candy on the table and we start rolling with our 4 fingers. 4 fingers. And then we have our cylinder again. We have our template, right? Now, again, 1 finger and we start rolling in the middle section. Rolling, rolling, rolling. We are creating a waist in our candy. Okay? Something like that, yes. Something that looks different in the middle, right? Roll the middle. It has to look like an hourglass. Everyone is ready? No? What's wrong? Tell me what's wrong and see if I can help you. Yeah,
Mila,
it
are you
looks
just having trouble shaping?
Yes, it was kind of getting hard, so add a little bit of water.
Oh yeah, you can do it again. Start like this in between your hands.
Make a sphere first. Oh, look, that looks great.
Yes, excellent.
And then make sure to give it a little bit of a waist, remember, where we press down with one finger so it's smaller in the center than it is on the ends, like with our first one.
One finger.
Yes.
Exactly. Excellent. Excellent. Okay, now please take your measuring tape or your ruler and grab the first candy. The first candy without the chili powder. We grab it, okay, and we measure. Mine is about 3.5 centimeters, okay? So I will go to my table and in the sample number 1, initial, in the I will type 3.5 centimeters, like this, okay? Now grab your second candy and then we measure. The second one is a little bit irregular still, but it's about 3.7 centimeters. Okay. Everybody's ready? No? Okay, measure. Anyone has questions, problems doing the shape?
Do we have any questions or problems with the experiment, Chloe?
Where do we put where we got the measurement of the centimeters again?
Yes,
So that's
here,
gonna go,
I.
there you go. Look at
Oh.
Dr. Angelica's table.
Yeah, look at my table. I means initial, F means final, and T means time.
Okay.
What we are doing today is basically a tensile test, like the test that I told you scientists and engineers use to measure how the material is deforming when we are pulling apart, okay? Everyone ready? Okay, now I am going to do this experiment for you to watch. I need you to leave the candies on the side because if we keep our hands with the candy, we will apply heat from our body and it will melt, okay? So I will do this experiment and then you will do it with me later, but I need you to see what I'm doing. So I'm going to pinch my hand, my face, and it's very soft. The same pressure I will use to pinch my head, my face without hurting myself, I will use to pinch both sides of my candy, okay? Very gentle, not too hard. And then at the count of 3, I will start counting and pulling until the mamba shoe breaks, okay? So at the count of 3, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. It broke at 8, okay? So now I will type time 8 on sample 1. So all together, I want you to do the experiment with me. Feel the force like as you were pinching your face without hurting yourself, okay? And then let me just very quickly make my candy, okay? So I can do the experiment with you. Everyone is ready? At the count of 3, we will start pulling, okay? grab the ends without too much force, just pinching your face, force. Okay, at the count of 3, I want you to start pulling. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 15, 16, 17, 18, 19, 20. Okay, at what second did your sample break? I want you to take notes. Take note here on the T. Okay, if we did the experiment correctly, our sample should break at the midsection, okay? If we didn't break at the midsection, it means we were applying too much force on one of the sides, but it's fine. The experiment still works, okay? Because we observe a change in shape. Okay, now is the time of the truth. We mix chili powder with our mamba shoe. So we are creating a nano composite. Our mamba shoe is a regular object and our powder is making the time of a nanomaterial. So we will see what happens. So again, grab your candy, pinch, okay? At the count of 3, I will start counting again. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, and 20. Okay, sorry, I'm counting and thinking and my numbers don't go very well. Okay, sorry about that. So mine broke at second 10. Okay, what I want you to see is that put your 2 candies together like this. This one is the original and this one is the one with the chili powder. Okay, let me use the other one because this experiment was not successful because I pushed one of the sides, right? But in my previous experiment, it broke perfectly in the middle, okay? However, you can see a difference, right? Which one was able to extend more? The one with the powder or the original one?
Oh,
you
Neela,
tell-
you had your hand up right away. Which one stretched farther?
The one with the powder.
The one with the powder. Okay, can we measure? So we will measure both candies. My original candy is 6.7 and I will take notes on the F because it's the final, right? And then the second candy with the chili powder, which is our nano composite, it measures 9.2 centimeters. Okay. Our experience is telling us that when we combine the chili powder with our regular candy, we improve the properties, right? We were able to observe that the material is stronger. That means that it can sustain force or pressure for longer without breaking, okay? So that's the importance of nanotechnology and nanomaterials. In a single thing, in a very simple experiment, we can see that we can improve and make things better, last longer for us to be safe, okay? So that's why nanotechnology in the new days is almost necessary, right? Because we are making our lives easier, okay? Do you have any questions? I hope you enjoyed the experiment and that you learned a little bit and that you liked it. And if you did it with your clean hands and with your parents' permission, you can eat your candy.
That was great. Thank you so much, Dr. Angelica. Can we give her a round of applause, everyone? That was awesome. Before we get into all of our questions, though, we have to do a brief activity. So everyone, make sure you have a piece of paper and a writing utensil nearby. You can use the back of your table if you want, or if you have a fresh piece of paper or a notebook, that's all right too. But like we normally do, we're going to ask a question and you can write or draw your answer. Either is totally okay. I'm going to give you 5 minutes to do it, but we can end early and get started